Okay, last time we talked about digital elevation models a little bit, did some symbolization, put a hillshade on it, and introduced the idea of some of the analytical tools you can use. In this video, we're going to do some more work with rasters. We're going to take a point data set and turn it into a raster for display. It's called point to raster interpolation. So here we are again in Kentucky, but what we want to do is zoom in quite a bit because this was a rather small study by one of my students. So let's go on into the the Big Hill Quadrangle in southeastern Madison County, northwestern Jackson County, and a little northeast corner of Rockcastle County in south central Kentucky, in an area, semicircular, more or less area called the Knobs, that sort of semicircles around the bluegrass region of Kentucky. So even more, we want to zoom in to this aerial photographs area, about 10,000 by 10,000 feet, and we'll zoom to that photo. And in fact, our study area is up in here. I'll go ahead and zoom to a 5,000 by 5,000 foot where I've done a DEM, or downloaded a DEM, and let me turn off the aerial photograph. So these are 5-foot resolution DEM files that are available from the Kentucky GIS outfit. They are made from very recently flown LiDAR data. Much too much storage space for large areas, but the detail is really nice here. I'm going to turn the air photo back on, and the symbolization is hidden under there anyway. I'm just going to leave the hillshade so you can see some of the rather steep topography to the east part. Let's zoom in even further, and here's our study area. The photo's beginning to pixelate at my the best I can find easily is 2-foot resolution. Right in here is the study area. The point of this whole study was to determine whether the soil fertility under a mowed grass pasture was any different from that under a relatively new stand of black locust trees. Black locust is a leguminous tree that's a real common invasive, not so much invasive, but it definitely colonizes cutover areas really quite readily. It's a dense, hard, dense wood, makes wonderful firewood, makes really good poles and fence posts and so on, very rot resistant. It is a little bit of a weedy species, and it has some pretty darn nasty thorns on it, so it's not all that popular with some farmers. It also is excellent bee forage when it's blooming in May. But in any case, I've read online in agroforestry blogs and so on how great black locust is for soil fertility, yet I've never seen any scientific data on it. So a student of mine a few years ago took on an independent study to measure the mineralization potential, the nitrogen, potentially available nitrogen essentially, for these two areas. And I'll go ahead and add the data here. So it's under my raw data folder, and it's called Soil In Data Big Hill. This is the Big Hill, the side of Big Hill Mountain. Okay, and we'll take that file. That will show up down here at the bottom. We right click on it, and we want to display the XY data. Or before I do that, let's look real quickly at the file itself, make sure it's what we want. So there were really two treatments. grass and trees. It was replicated 3 times. We blocked it by elevation. It's a semi-steep slope, and we thought it might be different from top to bottom, so we blocked it by elevation. And so this is a randomized complete block design is what it's called statistically. Here's my end mineralization potential, latitude, longitude. This is done by an anaerobic incubation. You flood the soil, hold it at about 37 Celsius, 95 to 100 Fahrenheit for a week, add some potassium chloride to extract off the ammonium that's been released over the week, and measure that. It's a pretty good index to the amount of nitrogen in milligram per kilogram, which is about kilos per hectare, for any crop that might be grown there. So now let's plot this. Display XY data. Longitude and latitude are my X and Y. It's not state plane, it's WGS84, a geographic coordinate system, and that should be okay. This is a warning. This doesn't have an object ID field. It will plot out as an events layer, they call it. What we want to do is turn that into a shape file. We right click on it, go down to data, export data, and we'll use this layer's source data, and it's in, let's do this. It's in the soils folder where I keep my soil fertility shape files and other similar stuff, and I'm going to call it soil in data Big Hill, and say OK. Yes, we do want to add it as a layer. Okay, we can turn off the events layer. We could actually remove it if I wanted. I'll just turn it off for now and minimize it. So here we are. Here's the grass, the 3 blocks by elevation. The downslope is this way to the southeast. In any case, let's symbolize this. And go to symbology, quantities, going to symbolize by nitrogen mineralization potential. It's categorized, that looks pretty good. The yellow to dark red color ramp looks pretty good. Let's pick these. Let's make the spots a little bigger. Properties for selected symbols, let's make it 8. That should be okay. Okay, as you can see, the lower values are out in the grass area and the higher values are in the tree area. I won't go into it in detail, but in fact the difference between these two locations, our treatment in effect, is statistically significant. So that's the stuff on the internet is correct, although I was skeptical. Now what we wanted to do was turn this point data into excuse me, into a raster. So we're going to interpolate, and that's done here under Spatial Analyst Tools, and there's a tool set called Interpolation. There are a number of different possibilities. I won't go into detail. We'll do inverse distance weighted, IDW, and we're going to have to go find our shape file. So Big Hill soil in data, or this is the one I just did. Doesn't matter, they're all the same. Okay, in min pot, let's go, let's call it Big Hill IDW 04. There's a couple of versions of this that should work, and we can take the defaults here. The default is an inverse square law. That is, the influence of each point in the interpolated means falls off as the square of the distance, and we'll say that should be okay, and it should display, but for some reason it's not right now. So let's go over here and display it. WGS 84 is a different datum than Kentucky State Plain, but it's not enough different to bother us at the moment. So let's symbolize this. Normally this comes out automatically with an assumed symbolization, but anyway, for some reason it's not doing it today. Let's use that same yellow to dark red, and just for let's format the labels so that the number of decimal places isn't 10. That's not really useful. Let's make it 0, and then we can say OK. Alright, so there we've got we've turned a discrete point data set into a continuous data set, and pretty much you can see the tree line right there. So that's point to raster interpolation by the inverse distance weighted method, and that'll be good enough for now.